Click the bell icon to get latest videos from Ekeeda.
Chapter name Transportation. Topic name problem number 12. So this is a problem where we are already given a initial solution and we are asked to find out the optimal solution, and we are asked whether the given solution is optimal or not. Let's first read the problem and then we will proceed to solve the problem. Here is the problem. The company has 3 plants and 4 warehouses. The supply and the demand in units and the corresponding transportation cost in rupees per unit are given below. On the basis of past experience, following schedule or the dispatch schedule has been finalized. So the problem gives us the initial solution. What the solution? From A to 2, 5,000 units. From B to 3, from B to 4. They have given us some allocations in bold and they have asked us 2 questions. First, is the above solution optimal? Find the optimal solution. So let's draw the diagram, and because they have already given us the solution in this problem, we are not required to solve the problem by VAM method. We can directly proceed and start solving the problem by Modi method to check the optimality of the solution. Let's start. So here's our table. So here is the problem. I'll just copy the whole problem as it is and then we will go for the Modi method. So here I have A, B and C. Here I have 1, 2, 3 and 4. Here is my supply and here is my demand. Let's have one more line here. So this is my cost 10, 12, 8 and my allocation 7,000 as given in the problem. And I have 7,000 here. Here the cost is 8, allocation is 5,000, 13 and 10, allocation is 500. And the total comes to 5,500. In the third column we have got 7, 6, 12. At 6 we have 4,500. And then in the last column I have 12, 14, 1,500, 3,000 and 1,500. We have 4,500 here. We have 5,000, 6,000, 9,000 and the total is 20,000. So this is the exact table we have copied. One of the values that might be missing here, I'll take it 10 here and I'll put 10 here. So this is my initial table now. This was given in the problem, and now the actual problem starts where we have to test the optimality of the solution. Since the allocation has already been given in the question, most probably the problem will be balanced. In this case 7, 5.5, 4.5 and 3,000 comes to 20,000. 5, 6 and 9 it comes to 20,000. So the problem is balanced. Now let's find out U and V values for the table. So we'll introduce a 0 here. In the first row, I have an occupied cell where the cost is 8. So 8 minus 0, it will be 8. Now in this particular column, I have an occupied cell 10. 10 minus 8. In this particular third row, I have got two occupied cells. One is 8. 8 minus 2, it will be 6. And 14, where 14 minus 2 will be 12. In the last column, I have an occupied cell where there is a cost 10. 10 minus 12 shall be minus 2. And in the second row, I have got a occupied cell 6. 6 minus minus 2, it will be 8. So we have calculated all the U and the V values from the table. And it can be observed that now we are supposed to calculate the delta values for unoccupied cells. Let's calculate the delta values for unoccupied cells in the next page. So delta values for unoccupied cells. So my first unoccupied cell will be A1 where the cost is 10. Our formula is delta is equal to cost minus U plus V. So my first occupied cell is A1, cost is 10. So 10 minus 0 plus 6. So A1, 10 minus 0 plus 6 comes to 4. Next is A3, 7 minus 0 plus 8. A3, 7 minus 0 plus 8. A4, 12 minus 0 plus 12. A4, 12 minus 0 plus 12. B1, 12 minus minus 2 plus 6. B1, 12 minus minus 2 plus 6. B2, 13 minus minus 2 plus 8. So B2, 13 minus minus 2 plus 8, which comes to 7. C3, 12 minus 2 plus 8. C3, 12 minus 2 plus 8, which comes to 2. So we have 1, 2, 3, 4, 5, 6 unoccupied cells. So we have got 6 unoccupied cell delta values, which are 4, minus 1 and 0. So 4, minus 1 and 0. Next we have 8, 7 and 2. So 8, 7 and 2. And it can be observed that one of the delta value is negative. So we can say that this solution is not optimal. So let's note down that line. Since delta value is negative, the solution is not optimal. So we need to improve this solution by making one more table based on Modi, which will decide whether this solution can be improved or not. Let's try the new table now. So let's draw the lines first. Let's copy the table without u and v values. Before copying the table, let's try to modify the solution by making a loop. Our loop will start from the negative value. So we have a negative value here, -1 delta value. Our loop will start from this point and come back to the same point, and directions can be changed only at occupied cells. So I'll start from here. I'll go to 5000. I'll go to 500. I'll go to 1500. I'll go to 1500. I'll go to 4500, and I will be back to the same point. So we started from this point, unoccupied cell. So I'll give it a plus. We jumped to 5000 minus. We came to 500 plus. We jumped to 1500 minus. We jumped to 1500 plus. And we again jumped to 4500. It will be minus. So there will be totally 3 minus and 3 plus in this case. Drawing a loop is a trick that can be learned only by practicing. You can't do it randomly. And remember one thing, for every unoccupied cell, there will be only one and one loop. Let's proceed further. Now, in the negative signs, we can see the allocations of 5000, 4500 and 1500. I'll cancel all these three. This 1500 minus 1500 will become 0. This 4500 minus 1500 will become 3000, and 5000 minus 1500 will become 4500. What we subtracted from these three particular cells will be added at the positive sign as 1500, 500 plus 1500, 2000, and 1500 plus 1500, 3000. So we made a loop, we improved the solution. Now this solution I need to copy on the next page. Here is my next table, A, B, C, and the demand, and 1, 2, 3 and 4, and the supply. Here I have got a U, here I have got a V. We need to recalculate V every time, both the values of U and V. My new values here are 3500, 1500, 3000, 3000, 2000, and 7000. So we have got 1, 2, 3, 4, 5, 6 occupied cells. Here is my supply of 5, 6 and 9, total 20. And here will be 7, 5.5, 4.5 and 3000. Now we are going to again check the optimality of the solution by calculating U and V values. I'll put a 0 here first. In my first cell, or in my first row, I have got 2 occupied cells. So 7 minus 0 will be 7, and 8 minus 0 will be 8. Then I have got one more occupied cell in the third column. 6 minus 7 will be minus 1. In the second row, I have got an occupied cell here, 10 minus minus 1. It will be 11. Then we need two more values, u at last row and v at the first column. I have got this occupied cell 10, 10 minus 8 will give me 2 here. And then in this row I have got an occupied cell here, 8 minus 2, it will be 6. So we have calculated all the u and the v values. Let's check the optimality by calculating the delta values for unoccupied cells. So delta values for unoccupied cells. My unoccupied cells are A1. A1 cost is 10 minus 0 plus 6. So A1 10 minus 0 plus 6. Remember the formula, delta is equal to cost minus u plus v. Then A4 12 minus 0 plus 11. A4 12 minus 0 plus 11. Then B1 12 minus minus 1 plus 6. B1 12 minus minus 1 plus 6. Then B2 13 minus minus 1 plus 8. B2 13 minus minus 1 plus 8, which comes to 6. Then C3 12 minus 2 plus 7. C3 12 minus 2 plus 7. C4 cost is 14. 14 minus 2 plus 11. 14 minus 2 plus 11, which comes to 1. So we have got all the delta values for unoccupied cells which are all positive. There is no negative value. That means that my solution is optimal. Let's first note down all the delta values. We have 4, 1 and 7. 4, 1, 7. Then we have 6, 3 and 1. 6, 3 and 1. And so I got all the delta values which are positive. So I can simply write here, since delta values are not negative, the solution is optimal. I'll just note down this point. Now let's find out the final solution. We have to obtain the optimal solution. Total transportation cost or the shipping cost will be equal to, but you simply multiply by the allocations with the cost. 3500 multiplied by 8. 1500 multiplied by 7. 3000 multiplied by 6. 3000 multiplied by 10. 7000 multiplied by 8. 2000 multiplied by 10. So we'll multiply this. 28 plus 10,500 plus 18,000 plus 30,000 plus 56,000 and 20,000, which comes to 28, 38, 48, 56, 86, 92, 142, 162, 500. So friends, this is our final solution, the optimal solution. This is the lowest possible cost. I can write it as the minimum, or I can call it as the optimum cost of transportation. Thanks for watching this video. Do subscribe to our channel Ekeeda.